Hello everyone, welcome back to Don't Gasp, It's Just JASP, your Learning Lab Tech tutorial. In this video, we're going to be going over how to conduct a single sample t-test, or you might have heard it as a one sample t-test here in JASP. If you'd like to follow along, you can download the CSV file we have on our website, and there is a previous video explaining how to import that into JASP. But for now, we're going to go ahead and begin by conducting our single sample t-test. Let's say our variable of interest for this one is caffeine, and we're going to be comparing our sample of OSU students, try to capture the population of OSU students, to national average for college students. So you're going to go to the drop-down menu first for t-test. We're going to do the one sample t-test. For this, you're going to want it set on student, and then you're going to want to pick the alternative hypothesis that you're aiming for. So we're going to go with a two-tailed test. We're just going to say that we believe OSU students differ from national, so other American college students, in their caffeine consumption. We're just looking for a difference. So we're going to keep our alternative hypothesis as not equals to, but if we're predicting that OSU students would have greater caffeine consumption, we do a one-tailed test with the greater sign. If we predicted less caffeine consumption, we'd do the one-tailed test with the less than sign. We're going to stick to two-tailed for this one. And for our test value, this is asking for your mu, so our population mean value. So let's say that the national average for caffeine consumption is 220 milligrams. And we're going to go ahead and bring in our caffeine variable over here. And then you can see that it gives us our t-value and our p-value immediately, as well as our degrees of freedom. So remember that for a single sample t-test, your degrees of freedom is going to be equal to n minus 1. So your sample size is minus 1. So our sample size is 35, minus 1 is 34. If you'd like a reminder, you can click on your descriptives here at the bottom to see your mean, your standard deviation, then your standard error. If you'd like to add effect size, you click the effect size button here. It'll give you Cohen's d. So if we were to interpret these results, we see that our t-value has a significant result because our p-value is less than our alpha 0.05. This can differ depending on which alpha you set, but traditionally you go with an alpha 0.05 unless stated otherwise. So our p-value is less than 0.05, which tells us our t-value is significant. And it's in the positive direction, so this is telling us that OSU students had higher caffeine consumption. And then our Cohen's d over here of 0.369, that tells us how strong this difference was. We're going to go ahead and call this a medium effect, but check your instructor guidelines for differences in interpreting Cohen's d value because they may differ. Now, for calculating a 95% confidence interval on the sample mean, it's going to be a little weird for a single sample t-test in JASP. I recommend go ahead and opening another one sample t-test option here. Bring over your variable, keep it on student, but keep your test value equal to 0 because for the confidence interval, you're going to click location estimate, confidence interval, and you can set it to 95%. It's centered on the mean difference. So by having our test value 0, our mu 0, that sets our mean difference to our sample mean of 252.171. And then it gives you your lower upper bounds centered on that sample mean. So you would do that separately. You absolutely ignore everything that's going on with your T and P when you're doing this to calculate your confidence interval on your sample mean. So that's when you refer to what you did previously for your significance and effect size, but this is how you calculate your confidence interval. But that is all you really need to know for conducting the single sample t-test. Hope you found this helpful. Remember, stats are whack, but we've got your back. Have a wonderful day.